Hello everyone, and warmly welcome to this course on forests and climate change. This course is also part of the Climate University course tray. My name is Anna Lintunen. I'm university researcher at the University of Helsinki. Here you can see the course outline. So first there is the introduction to the course, which is this video you are just now watching. And the other sections on the course are carbon and water-mediated impacts of forests on climate, albedo and aerosol-mediated impacts of forests on climate, section on forest ecosystem and biodiversity, section on forest use, then modeling forest-climate interactions, some example cases of forest use and their climate impacts, and finally, some conclusions. There are some expected learning outcomes listed here on this course. So the student will be familiar with various climate impacts of forests. The student is familiar with real-life decisions and forest management practices done related to forests and their impact on climate. The student knows how to critically examine public discussion on the roles of forests and forest management effects on climate change. The student can reflect on different values related to forests. And the student can explain the linkages between forests, climate change, and biodiversity. Then few course practices. So please check the registration guidelines from the course platform. This is a course that you can take independently, meaning that no real-time interaction with teachers is involved. However, you can always ask questions, for example, by email. We are happy to help. Each course section is followed by a quiz that you need to pass together with the final exercise. In case you do not plan to take the credits, or you don't want to test how much you learned, you can skip the quizzes and the exercise. And after then passing all the sections, you can get the course credits, if you so wish. Here you can see the people behind the course materials. So Helena Rautakoski is a PhD student from the Finnish Meteorological Institute. Pauliina Schistl-Aalto is university researcher at University of Helsinki. Simone Bianchi is researcher at Natural Resources Institute Finland. Ritika Srinet is postdoctoral researcher at the University of Helsinki. And me, you already know. Few words about global warming. So the global temperature has already increased by 1.2 Celsius degrees from the pre-industrial times. And currently, the global temperature is increasing approximately 0.2 Celsius degrees per decade. However, the high latitudes are warming even faster than the global average. And for example, in Finland, the temperature has already increased by approximately 2.3 Celsius degrees from the pre-industrial times. What is then causing the global warming? So greenhouse gas phenomenon is a natural phenomenon. And without it, the Earth would be a cold place. So in greenhouse gas phenomenon, the solar radiation is absorbed by the Earth's surface because that can penetrate well the greenhouse gas layer in the atmosphere. Earth's surface then emits thermal radiation that greenhouse gases in the atmosphere absorb, and this way prevent escaping to the space. Due to the anthropogenic emissions, the CO2 concentration in the atmosphere has increased from pre-industrial times when it was around 280 parts per million to current 420 parts per million. And this is why larger share of the thermal radiation emitted by Earth's surface is absorbed by the atmosphere and remains there. So how are then forests relevant for global climate? Let's first look how climate impacts forests and then how forests impact climate. Because there is an interaction, kind of a feedback between global warming and the forests. So increasing frequency and severity of summer droughts is decreasing forest growth. It's even producing mortality of forests in many parts of the globe. Warming climate also increases the risk of biotic disturbances such as pathogens and insects. And it increases the risk of forest fires and wind damages. Warming climate also increases the growing season length in areas where the growth is temperature limited, like here in the boreal region. Warming climate also increases mineralization rate, so meaning that when temperature is higher, the decomposition rate is higher. So litter and other organic material in the soil is decomposing faster. And this way, the nutrients are mineralized for the use of the trees in a way faster. Atmospheric CO2 fertilization means that when the CO2 concentration is higher, the trees can photosynthesize more efficiently. So you can see from these colors that some of these impacts of warming climate to forest growth is clearly negative, but some of them are such that by now they have actually increased forest growth here in the north. Then there are also changes in species distribution caused by the global warming. So many species need to move towards the north when the temperature is increasing. And then changes in the competitive setting between species. So some species suffer more from the global warming than other species. And this produces differences in their competitive setting. How are then forests impacting climate? Let's first think about carbon dioxide. So trees and other green plants are photosynthesizing. And when they photosynthesize, they uptake carbon dioxide from the atmosphere and store it in the plant biomass. Also, forest soil is a big store of carbon dioxide. All living organisms also respire, so release CO2 to the atmosphere. And this is why you can see in this picture the arrows going to both directions. And when a forest absorbs more carbon from the atmosphere than it releases, it acts as a carbon sink. So carbon sink means that the amount of carbon stored in the forest increases. Then is the albedo impact. So albedo is the fraction of sunlight that is reflected by a surface. And as forest is quite dark surface in the summertime, especially when compared to the, let's say, open field or grassland. And the darker the surface, the more it absorbs the sunlight. And this way, forest impact to climate, the albedo impact is actually warming the climate. So carbon dioxide impact is typically cooling the climate, but albedo impact is warming the climate. Then forests also emit volatile organic compounds. We cannot see them, but we can sometimes smell them, especially after a rain in the forest. And these volatile organic compounds contribute forming aerosols, small particles in the atmosphere. And these small particles further can produce clouds by acting as cloud condensation nuclei, like more small seeds that form cloud droplets. And both these aerosols and clouds reflect sunlight back to space. And this is why aerosols and through aerosols and clouds, these volatile organic compounds are having a cooling impact on climate. So forests have many different kinds of impacts on climate. Let's here look one example forest. This is a pine forest in Finland. And let's look how it impacts forest through one rotation period. And rotation period means in forestry the time period from the establishment of the forest, let's say planting of the small trees, until it's cut down. So on this figure, we have on y-axis change in radiative forcing at stand level, meaning that when the radiative forcing has a positive value, it means a warming impact on climate, and when it has a negative value, it means a cooling impact on climate. On x-axis, we can follow the time from the planting of the forest. Okay, let's first look at the carbon dioxide. So when the forest is young, it is actually emitting CO2 more than it is uptaking CO2. So the forest is a CO2 emitter until it grows enough so that it starts to uptake more CO2 in photosynthesis. That is, it is releasing in respiration. And also have to remember that when we talk about respiration, also soil respiration is included. So all the decomposition processes and respiration of microbes in the soil. Okay, so after, let's say, 20 years, the forest turns into net carbon sink. And after that, you can see that the carbon sink gets stronger. There are few thinnings done on the way. But then at years of 60 years, the forest is clear cut. So the trees are cut down and taken away, and the forest again turns into carbon source. And after planting in let's say 20 years, it again turns into carbon sink. Let's then look at the albedo effect. So a young forest is quite, the surface is not very dark. And this is why the albedo effect is small in a very young forest. But after the canopy closes, so meaning that the canopies grow, it becomes darker, and after that, it has a warming impact. And after the canopy has closed, so there is no more empty space in between the tree canopies, you can see that the albedo impact remains quite unchanged until the forest is cut down. Then the albedo effect goes again to 0. So you can see here on the right-hand side, the total impact. So we can see that from this whole period we have been looking at here, the carbon dioxide impact is strongly cooling the climate, whereas the albedo impact is warming the climate. Then let's look at aerosols. So when the forest is young, the aerosol emissions are quite small, but after it grows, it starts to emit more and more aerosols, and they have a cooling impact. So we can see that it's almost like a mirror image to the albedo impact. And here we can see on the right the total impact of aerosols in blue color, and this is a cooling impact. And then in the end, let's look at the total impact when all these are summed together. We can see that the total impact on climate follows quite nicely the carbon dioxide impact in this case, because the albedo and aerosol impacts more or less counterbalance each other. So in general, if we think how higher cutting levels impact the climate, and now we are talking in general, of course, these impacts on climate, how forest management impacts climate depends on the specific conditions, the specific forest type and the growing conditions. But in a big picture, we can say that higher cutting levels lead to warming impact of climate in terms of CO2 as the carbon sink of forest decreases. Cooling impact in terms of albedo, as there is less tree cover, which absorbs solar radiation. Higher cutting levels lead to warming impact regarding aerosols, as less trees emit less volatile organic compounds, and thus aerosol formation is decreased. Higher cutting levels lead to cooling impact regarding the substitution effect, as some fossil fuel emissions are avoided through the use of wood material and energy. And this is what is called substitution effect. And in total, higher cutting levels typically lead to a warming impact because the warming impact of decreased carbon sink dominates. And in more depth to these different aspects, you will go during the course. Okay, so I hope you all enjoyed the course. Here you can see my email address that you can use for any possible questions. Thank you.